Welcome to the Apidae Calibrator demonstration. Apidae Calibrator is a tool for calibrating building energy models against measured data. The first thing we need is, of course, an energy model. The second thing we need is a weather file from you, and we recommend that you use AMY files. Find them somewhere instead of trying to normalize your EPW, your standard design files. But once those are uploaded, we'll check the model for a few things, make sure it runs, and parse it so that we can have access to the inputs. Parameterizing the model is exactly the same as it is in our other tools. Here is the IDF file. You can use the search functions to find the objects that you're interested in and look within the objects and find the fields that you want, and within those you give them a label and press add to tag them as a parameterized object. Once you've done all the objects that you're interested in, you need to give them a range, a min, max, and a sampling density, or the number of steps within that range. The next step is to actually choose the outputs, which is different than our other tools because it involves using measured data. So let's take a look at that. On the left are the outputs from the Energy Plus simulation that are available to you. And on the right is an area for uploading measured data. Once again, you can use the search functions to find the simulation outputs that are meaningful. And on the right, upload a CSV file that has the data that you need to calibrate against. Once that's uploaded, you can see that we'll show you a little version of it so you can make sure that it's the right file and that you know which column is the one that you're interested in. In this data, we have daily gas use for this building measured every day. And as you can see, there's a large chunk of time when the loggers were not working. So this has a big open period of data in it. We automatically mask that out during the process of calibration. So once you have the file there, we need to know which file to use, which column in that file to use. Tell the start date of that first timestamp data. That would be the start time of the first, where the data starts. And then we need to know, what the time step is. So in this case, we're using 1 day data. Having that, you can basically press run. We'll tell you how long it's going to run, and you have some options for making it faster. Once it's completed running, what you'll get is a CSV file with all of the simulations that were run and a little dynamic visualization tool to help you understand what happened. In this case, you can see the CV, RMSE, or the fitness is on one axis. You can just play with it and find out what the well-suited simulations looked like. It's also interesting, on the far right is the generation or the process of the algorithm. So it's cool to look through that and just see this is where it started, and you can sort of watch the things settle as it goes. This is the algorithm looking for a good solution as it progresses. But all in all, what you'll get is a list of good solutions that you can then, just look at and decide if they make sense and if they're useful. This thing says that it calibrates well with a range of the flow rate of the ERV at this, but you'd happen to know that's within this range, so you can trim that. These tools will provide a rich data set and an interesting graphical way to help you make good decisions, but they don't take the place of an experienced engineer. They'll just help experienced engineers work really quickly. So that's our quick tutorial. It's very fast. Feel free to join us at apidaelabs.com for more information. We look forward to seeing you there.